When studying relationships, graphs, tables, and formulas are just different ways to represent our understanding of how the quantities change together. This is sometimes easier to understand when you have a specific context like the ones we've looked at. However, the same ideas apply to relationships between covariant quantities without a specific context. For example, suppose y varies at a constant rate of change with respect to x. The constant rate of change of y with respect to x is 1.5. And we know that y equals 2 when x equals 5. Now, since we know that y equals 2 when x equals 5, we can plot the point 5, 2 on this plot. And notice that we have values of x on the horizontal axis and values of y on the vertical axis. Now, as x varies away from 5, we have a vector representing the change in x, another vertical vector representing the corresponding change in y. And since the constant rate of change of y with respect to x is 1.75, we know that the value of this change in y will be 1.75 times as much as the corresponding change in x. So we can represent this. So we know that delta y is 1.75 times as large as delta x. Now we can use this relationship to determine the value of y given any value of x. So if we pick a new value of x, we can determine how much x changed by, we can determine the corresponding change in y, and then we can add this change in y to the initial value of y. Now we can do this for any value of x, so we can actually imagine x and y varying together while we pay attention to this new point x comma y. So as x and y vary together, we know how they're related. And if we go ahead and trace out this new point x comma y, what we get is a graph showing how x and y are related. So this graph shows all possible pairs of x and y. When we pause the variation at any moment and look at a specific point, we can represent these simultaneous values in a table of values. So let's look at a table of values. First of all, we know that when x equals 5, y is equal to 2. Now, if we look on the graph, we see that if x equals 8, y will be equal to 7.25. So we can actually add this to our table of values. So we've got a new entry in our table of values. Similarly, if we look at when x equals 2, y is equal to negative 3.25, and we can go ahead and add this to our table of values. Now, since we're building this table of values, we can actually make it as large as we want. So if we go ahead and just add as many points as we want, we can make this table longer and longer. However, our table will be quite long before we describe in detail how x and y are really related. So a better way to do this might be to write a formula that expresses y in terms of x. So from previous modules, we've seen that the formula expressing y in terms of x will be y equals 1.75 times x minus 5 plus 2. Now, if we evaluate the formula at some value of x, we can see that the formula models the same reasoning we use to find new values of y on the graph. So for example, let's assume x is equal to 1. Then using our formula, y will have to be equal to 1.75 times 1 minus 5 plus 2. And this will be equal to negative 7 plus 2, which will be equal to negative 5. So when x equals 1, y will be equal to negative 5. Now we'll notice that using our graph, if we look at x equals 1, the point 1, negative 5 is indeed on our graph. And we can also add this to our table of values to see that we know that when x equals 1, y is equal to negative 5, and we can see this using any one of our three representations. Now, let's look at a slightly different scenario. Since graphs, tables, and formulas are just our attempt to represent our understanding of how quantities change together in some situation, the features of these representations are fully under our control. We can pick how the details will be represented based on how we're thinking about the specific relationship. For example, the relationship between x and y we've been looking at, we can use two different graphs to visually model the same relationship between x and y. So in one case, we can represent values of x on the horizontal axis, and we can represent values of y on the vertical axis. And then the graph shows the relationship between x and y. Now on this other side, we can represent values of y on the horizontal axis and values of x on the vertical axis. And this graph still represents the same relationship between x and y, but you'll notice that the graph looks differently than it did in the first case. Even though we are representing the same relationship, points on the two graphs are interpreted differently. In the first case, the point 5,2, so the point 5,2 is on the graph, and this means, so this point 5, 2 means that when x is equal to 5, y will be equal to 2. Now in the other case, we see that the point 2, 5 is on the graph, but in this case, the first coordinate represents a value of y, and the second coordinate represents a value of x. So both of these points represent the same information, but they are different points on the graphs. Now, this demonstrates two very important issues. First, the specific details of our representations can change depending on how we think about the situation and what we want to emphasize. Second, it's very important to pay attention to variable definitions, what the axes on a graph represent, and how tables are labeled in order to give meaning to the values we encounter when working within a situation.